All near-Earth asteroids are monitored by NASA to predict potential impacts. Any NEOs that are larger than 100 meters in diameter and pass within 4.6 million miles, 0.05 astronomical units, are classed as potentially hazardous asteroids. 2017 EG3 was first observed by the Mount Lemmon Survey Observatory, northeast of Tucson in Arizona, on March 7. Today it came within 4 lunar distances (LDS) of the planet, or 0.0112047, just over 1 million miles away. The Moon orbits at a distance of 0.002570, around 238,000 miles. It will pass by again on Monday, but will only come within 55 LDS.
100 years of killer strikes starting in 2017. A previously unknown asteroid belt has been located in deep space and is now hurtling towards our part of the solar system. It means a global killer could collide with Earth as soon as 2020, wiping out life as we know it and changing the climate for millennia. The terrifying predictions came as NASA revealed disturbing new data showing 400 impacts are expected between 2017 and 2113, based on new observational data of objects seen in space over the past 60 days. Most will have a maximum diameter of around 100 meters, the size of 7 double-decker buses, and the potential to cause significant damage. But concerned scientists warned a colossal monster is also heading our way, with one mega-asteroid threatening Earth in just 6 years. It follows claims this week by physicist Professor Brian Cox that a bus-sized asteroid, named 2014 EC, came within 61,637 kilometers, 38,300 miles, of Earth in March. He said there is an asteroid with our name on it and it is only a matter of time before an asteroid large enough to wipe out the human race collides with Earth. Many believe an asteroid was responsible for killing the dinosaurs with a similar life-changing event, potentially just around the corner. Professor Bill Napier, an astronomy expert at the University of Buckingham, said a strike by either an asteroid or debris from a comet could have devastating consequences. He said, "If something like this happened, depending on where it hit, it would be absolutely life-altering. The atmospheric chemistry would be upset by cutting out sunlight. It would be like a nuclear winter and could last for tens of thousands of years." These comets are 200 to 300 kilometers, 186 miles, in diameter. They are sheer monsters and could sterilize the Earth if we are hit by one. The more immediate risk comes from sub-kilometer, smaller asteroids, and there are tens of thousands of these in space which are quite capable of causing damage on a regional scale. One hit Siberia in 1908 and luckily it was not in a populated area. Had this happened in London it would have wiped out everything within the M25 and you would have heard the collision in another country. And experts warned of the possibility of something much bigger striking Earth in 2020. Asteroid 2012 DA14.
All of us on this planet are on the brink of a kind of close encounter. A big asteroid is hurtling through space, and it's supposed to miss us by a cosmic inch, just 17,000 miles. That's closer than some of our weather satellites. In fact, it's so close, scientists are springing into action, and here's ABC's Neil Karlinski.
Right now, while you're watching this, a chunk of space rock big enough to level a city is hurtling towards our planet 8 times faster than a speeding bullet. The good news is, scientists say it will miss. The scary news is, the 130,000 metric ton asteroid called DA14 is the size of half a football field, and it will be much closer than the moon. In fact, it will thread the needle between Earth and the roughly 600 satellites around us, the ones that your cell phone relies on, possibly even smashing one to smithereens on its way by. But if that's why you're thinking this is all still a long, long way from all of us way down here walking the streets, you may want to think again. The last close call turned out to be a direct hit. It was 1908, and luckily it hit the middle of nowhere, Siberia, decimating 1,000 miles of trees, but no people.
If a very large asteroid hit, it would probably create the same kind of disaster that wiped out the dinosaurs.
Amazingly, no one knew DA-14 was headed our way until a Spanish dentist and amateur astronomer randomly discovered it a year ago. NASA doesn't have the resources to look for asteroids, which is why a trio of American astronauts and rocket scientists are raising money to launch their own asteroid early warning system called Sentinel, a dedicated telescope scanning the stars for threats.
This asteroid is a wake-up call that we should be looking out there. These things do hit the Earth.
Scientists say we can keep the planet safe if we just know what's out there headed our way.
Ulchodas, a planetary astronomer at NASA's Jet Propulsion Laboratory, JPL, said, the orbit for 2012 DA-14 is currently very Earth-like, which means it will be very close to Earth on a regular basis. Professor Napier said the Earth is at risk of two types of strike asteroids, which are lumps of rock, and much larger comets formed from ice which shatter into billions of diamond-like pieces as they hit the Earth. He said though some famous comets like Halley's Comet present little risk, there are similar ones out there, which could have catastrophic effects. The Swift-Tuttle Comet, discovered in by Lewis Swift on July 16, 1862, group warned an impact by an asteroid larger than 1-2 kilometers could throw the climate into chaos, triggering crop failure and loss of life. An impact by an object larger than about 5 kilometers is damaging enough to cause mass extinctions, it said.
NASA is currently tracking 1,717 near-Earth objects that are considered potentially hazardous asteroids due to their size and orbits. Approximately 70% of the Earth's surface is covered by oceans, so an asteroid is most likely to impact the water. An ocean impact within 10 to 20 kilometers of a populated coastline would be devastating, causing severe flooding, destructive shock waves in the air, high temperatures, and hurricane-force winds. The threat from an ocean impact far from land is more difficult to assess. In particular, we want to know if destructive waves created by an impact can travel long distances to populated shorelines. To understand these threats, NASA held the Second International Workshop on Asteroid Threat Assessment, focusing on asteroid-generated tsunamis.
As part of this effort, scientists from Los Alamos National Laboratory are using high-performance computing to investigate how an asteroid's kinetic energy is transferred to the atmosphere and ocean.
Los Alamos scientists ran an ensemble of 3D simulations, varying the asteroid's size, the angle of impact, and whether or not the asteroid exploded in an airburst before impact. The height of this airburst was also varied. We used X-Rage, a parallel multiphysics Eulerian hydrodynamics code. X-Rage uses adaptive mesh refinement to continually subdivide computational cells in important areas, applying more computing power to where it's needed. Our simulations contain 3 materials: a basalt asteroid, static air, and static water. Initially, all kinetic energy is assigned to the asteroid. By studying different runs from the ensemble, we see the effects of varying asteroid size, angle of impact, and airburst. Here, a light-colored pressure wave shows the asteroid's effect on the atmosphere. In addition, a large plume of water rises from the largest asteroid impact. Clearly, more kinetic energy is transferred to the water in this simulation. Slicing through the dataset reveals more detail. The largest impact simulation shows development of a transient crater and a large plume of water and water vapor. Here we see 2 cases varying asteroid size. On the right are plots showing the transfer of kinetic energy from the asteroid to the water and air. Pressure waves in both the air and water show differences in the transfer of kinetic energy. Colliding shock waves in the atmosphere and water, as well as the wind at the water's surface, hinder the creation of a propagating wave. Here we see the difference in energy transfer with and without an airburst. Whether or not there is an airburst changes how much kinetic energy is transferred to the air and water. An airburst breaks the asteroid apart so that much of it skims the surface of the water rather than slamming into it. For the same size of asteroid, this results in a much smaller effect on the ocean. Interestingly, there is a stronger wave interference in the direct impact simulation, but such an impact is more likely to create a tsunami because of the greater height of the splash. This may indicate that a tsunami is more likely to be formed during a direct impact than an airburst. Previous simulations had led us to believe that the opposite was true. A feature discovered through this visualization is a pressure enhancement uprange of airburst impacts. Two pressure waves combine to create this, one from the asteroid in its trajectory, and one from the explosion when the asteroid material hits the water. This may affect wave propagation and will have to be studied. By visualizing just the water in an impact simulation, we can study the formation of the tsunami wave. Immediately upon impact, a transient crater is created, and a splash curtain is thrown high into the air. Water rushes into the crater,